In this video, I'm going to work on some of the additional processing methods that we can use through Numpy package. So let's import Numpy as NP like before. I'm going to define a matrix called mx1, and we're going to say this is a range of 70, basically values from 0 to 69. And I'm going to reshape this into a matrix that is 7 by 10. So basically 7 rows and 10 columns. So let's call this matrix. So we see that now we have 7 rows, 10 columns, and we have values from 0 to 61. The way that we defined it. I can also create another matrix, let's call it mx2, and so I'll say a range of 80 values and shape it where it's 5 rows and 16 columns. Let's call the second matrix. You see that those values are created again in the same way that we were expecting. Now, another method that you can run is transposing the matrix. Transposing basically replaces the columns and the rows of a matrix. So let's say if the shape of the matrix is 5 by 16, once you transpose it, it's going to be 16 by 5. So you can say simply mx2.t, standing for transpose, and now we have all the values in a different shape. So our matrix now have 16 rows and 5 columns. And once we have that, now it's easy to multiply. We can multiply a matrix that is 5 by 16 by a matrix that's 16 to 5. Again, probably from high school matrix algebra. So how can we do this? We can run np dot. A dot function essentially is multiplying two matrices. So here I can say multiply mx2 by a transpose of mx2. So the output of this should be a 5 by 5 matrix so let's run this. And we see that now we have all the values multiplied and then summed across the columns and rows, coming to a total of 5 by 5 matrix as a result of multiplying these values. You can also create a matrix using an array with values that are following a normal distribution. So that's something that's very useful if you're running statistics or you want to use Numpy in order to work with other software, other packages. We always want to call values that are following normal distribution. So in order to do this, we call from numpy.random, we import rand_n. And once we have rand_n, I can define a matrix. Let's call it A1. I'm going to say np.random.rand_n, and I can say the values, the number of values that's going to be in this matrix. And similar to what we did above, I can reshape this into a matrix that has 5 rows and 4 columns. So let's call A1. I can also create another matrix, A2. So let's see what would happen if we create two different matrices in terms of results. Now I'm going to call A1. So I have an array, as I mentioned, 20 values following normal distribution. And if I'm running A2, it's similar in that there are values that are following normal distribution. However, these are different values, so randomly created. And if I'm printing each of these, every time I'm running the code, the values within those matrices might change. So if we want to keep those values, we need to copy those matrices into different variables using the copy function that we covered before. Now let's print these together. I'm going to separate them using a line. I probably need two lines here, so I say backslash and backslash n, and that will show us these two matrices that are separated by basically two lines. So there's one at the end of A1, and there's then the second line that's empty. There is also another way to create these random matrices. We can simply import rand n, and then we can call a tree using a method called rand n. So we say rand n, and then give me a matrix that has 4 columns and 5 rows. So once I create this, let's run a tree and see how the values look like. So now we have a new array that's similar in shape, but again, it's a little more concise in terms of the code. And this, in the same way that we could multiply the matrices, we can also add the values within the matrices. So if matrices are the same size, we can basically add them all up. If they're in different shape, the np.add will add the values as much as A1 can handle. So all the values in A1 will be covered, will be considered and be added to A2. So here we have A1 and A2, and we have the results as the way you can see. So this is also, again, it's a matrix of 5 by 4. There are also additional kind of calculations you can do, basically universal functions that you can call using Python, a Numpy package. So let's see if we want to look at these values. I'm just gonna import web browser. This is a way to call a URL. I'm just gonna say URL is equal to, and I have the documentation. I can just copy that and print it here. So this is the link to the documentation, and you can say web browser.open URL, and this is the way basically again to open a web page through a Python compiler. So let's run this. We should get a true value here. That means it works. And then these are example of all the math operations we can do. So we talked about adding. Dotting was matrix multiplication. We also have multiply, which will multiply each argument. So multiplying arguments element-wise. We can subtract. We can divide. There is floor division. We can change all the values negative or positive, and we can use first element by the power of the second element. And I'll let you guys go through this and see and get familiar with other ways that other methods that we can call in a Python package. All right, so the last thing I want to talk about here is how to handle data that's stored in a different file, let's say in our database, in order to call it into Numpy and be able to work with it. Let's say first thing first, I want to create a matrix similar to what we have done before. So I'm going to say matrix of 30 values, reshape 3 by 10 and mx. So we have our matrix created. Next, what I want to do, I want to save these values. So I'm using a save text method, and I'm gonna now have to identify the name of the file. Let's just call it mx data, and it's usually stored in a text file. And what do we want to store? I'm gonna store mx values, and because we want to be able to work with this, let's say in a matrix format, our delimiter would be Basically, delimiter would be the value, how you're basically separating between the values. Commonly, we are using a comma between values, which is in the same way that you can see here as well. And that's also the way we can open a text file without a problem and import it later. So let's just, let me just add some information here. So this is basically saving the array to a text file. If I'm running this code, now I can go back to my, if I'm checking the values in my storage in the same folder where we were storing this Python notebook, this Jupyter notebook, I see that now I have a new file that's just created. So if I'm opening the file, we have all the values that we saw that were created in there stored. So it says 1, 0, 1, 2 with a lot of decimal values in the file that we specified. Okay, so let me go back. So here is again the way to save it. Now once I have the file saved, I can load that back. So let's say mx10 is equal to np.loadText, and you specify the name of the file. I can just copy paste it, and you need to specify what is the value between each of the variables. If I'm checking my data, the values are separated by a comma. This means our separator is comma. If the values were separated by a space, you can use a space. And that's again a way to help Numpy understand how each of these values are going to be separated from each other. So if I'm running that and I'm calling mx10, let's see what happens. So it will load the file. Now that's that each of the values are now turned into float, but it will load the same values and it is stored it in a new matrix if possible. If it wasn't possible, let's say if the data did not exist. Let me just change the name of this data file. If our data file did not exist, then I should receive an error which says it's a traceback error. So that file does not exist. So mx data not found. All right. If I'm adding the underscore, the dash here, I should be able to retrieve my file in the same way. We can also import data from CSV file in the same way that we did. So let's try to import data from CSV files. And you can also manipulate the data upon import if that's a thing you need to do. But let's say import numpy as an np. I'm going to say d1 is equal to numpy.gen. Let's call generate from text. So we're looking for generate from text, a CSV file. So let's look at now I'm going to call, I have a file that's stored already in the same folder. I have this called Boston CSV. If it's not in the same folder, you have to specify the directory where it's stored, but because it's in the same place, I'm just going to use the same value. What else? I have to specify the delimiter. So we say delimiter is equal to comma. I can just use that value from up here. And also the last value you want to use is names is equal to true.